Hello everyone, welcome back. In our previous video, I have briefly discussed what a AI agent is. What is the basic difference of a AI agent and a AI chatbot? Today in our video, we are going to build a real working agent from scratch, running entirely on your machine using Google Colab's free T4 GPU, the Qwen 2.5 model via Ollama, LangChain and LangGraph at completely zero cost, no API key and no monthly bill. The first thing we do to install our 4 Python packages: LangChain, LangChain Ollama, LangChain Core, and LangGraph. This takes about 30 seconds. I have already installed it because it is time consuming process. The other dependencies has already been installed so that the Ollama runs perfectly in our Colab machine. Now, to install Ollama, the first thing we install the Ollama binary using the install script which is already available in the Ollama documentation. This may takes about the 20 seconds. Second, we start the Ollama server in the background using subprocess popen. We pass the stdout and stderr to devnull because we don't want to flood our notebook with server logs. Then we wait 5 seconds and ping the server to confirm it is running. And third, and this is the most time consuming process, we pull the Qwen 2.57b model. It is about 4.7 GB model. On a fresh Colab runtime, this takes around 3 to 5 minutes depending on Google's network speed. After the first run, it is cached, so subsequent runs are already instant. So while running, we can see the first stage that it is installing the Ollama, and Ollama has already been installed. The second step, which is the starting of the Ollama server. When the Ollama is perfectly running, we install the Qwen 2.57b model, which is around the 4.7 GB model, and after installing, we can see that our setup is complete with the model's name and server address. Let's run the sanity check at the bottom, and this sends one quick message to confirm the model responds correctly. So we have taken a simple message that reply in one sentence, what is an AI agent? Our model Qwen says an AI agent is a software program that can perceive its environment and takes action to maximize its chance of success in achieving specific goals. So we can see that our model is working perfectly. Now we give our agent tools. This is where it stops being a chatbot and starts being an agent. In LangChain, a tool is a Python function decorated with tool. The LLM does not see the function code. It only reads the docstring. So the docstring is critical. It needs to clarify. It needs to clearly explain what does the tool do, when should you use it, what format does the input need to be in. Let me walk through the tools. First, tool 1, the calculator. It takes a math expression as a string and it evaluates with safely and returns the result. Notice the safe global dictionary. I have removed all dangerous built-ins and only the allowed math operations and a few safe functions like absolute, round and power. The math module is included so the agent can call math.sqrt and other functions. This is important. Never use bare eval function without restricting the bulletins. Tool 2 is our web search. This is simulated today, but the interface is identical to what you would use in a real search API. The docstring tells the LLM, use this for a recent events, current technology, and fact you are not confident about. In a real project, you would replace the function body with a DuckDuckGo API call or Trapiti. On rest of the agent code stays exactly the same. I have populated the mock knowledge base on the real accurate information about Qwen, AI agents, LangGraph, and Ollama, so the search result will be genuinely useful during the demo. At the bottom, we put the both tools in a list of tools. This list what we have handed to the LangGraph. Both tools are registered, and let's us build the agent. So This is the heart of today's session. Let me walk through it section by section. Section 1. Agent state. This is agent's working memory. It is a type dict with one field, messages. The annotated type with the operator add means every time a node returns a new message, they get appended to the existing list, not replaced. So the agent always has full context of every messages, every tool call, and every tool result. Section 2. We initialize chat Ollama. Pointing to our local server port 11434, temperature 0 means deterministic, consistent outputs. Important for agents because you want reliable behavior. I have also set numPredict to 10224 to limit response length and keep things first. Then, and this is the key line, we call LLM.bindTools. This attaches the tool definitions to the LLM object. From this moment on, we call LLM with the tools invoked. The model knows these tools exist and can choose to call up them. This is the section 3, the system prompt. This tells Qwen its role, what tools it has, the rules it should follow. Rule 1 says always use the calculator for arithmetic, never compute in your own head. This prevents hallucination on math. Rule 3 says think step by step. This activities chain of thought reasoning which dramatically improves quality. Section 4. The agent node function. This is the LLM's think step. Every time this node runs, it pretends the system prepends the system prompt, combines it with all messages in all state calls, Qwen and returns the response. The print statements gives us visibility. We can see in real time whether the agent decided to give an answer. Section 5. The tool node. This is the pre-built LangGraph component that handles tools execution automatically. You just pass it tools list and it handles calling the right function, passing the right arguments and packaging the result as a tool message. The section 6 should continue. This is a router. It looks like last message. If the LLM made a tool call, we use tool. If you give a plain text response, we return end. This simple if statement is that what it creates the intelligence of the loop. Now, the graph construction. We create a state graph, add our two nodes, set entry point to agent, add a conditional edge for the agent using should continue. If use tool, go to tools. If end, stop. Then add a fixed edge from the tools agent. That fixed edge, tools to agent, what it creates the loop. Now let me run it. You can see agent has compiled and the LangGraph agent is completely ready. Now, I have written a helper function that runs the agent and displays the output cleanly. Let me run our 4 demos. So this is the demo 1. Demo 1 asks two things at once, a percentage calculation and an AI agent news. Watch the output carefully. See what agent is thinking when decides to use the both tools, decision, use tools calculator and web search. It computes the percentage and gets 351. It searches for AI agent news, gets back to our mock results. Then it synthesizes both into the coherent answer. This is multi-tool use in a single turn. This is the demo 2. Demo 2 is a two-step math problem. Speed of the train, then time travel of a different distance. Watch if it uses calculator once or twice. The agent is thinking, it called the calculator twice. You can see that it has the first call of the calculator and it is the second call of the calculator. So, two more separate tool calls, two results and one final answer. The agent chained multiple tool uses correctly. So, our last answer is at a speed of 90 km per hour, it should take the train 6 hours for travel 540 km. Therefore, the answer is the train of the 90 km per hour and it would take 6 hours to travel 540 km at the same speed. Now it is the demo 3, and this is an important, a simple factual question. Let me run it and see the output. Notice what happened. Decision, give final answer. No tool calls at all. The agent knew Delhi and Hindi from its training data and did not waste a tool call. The tool used judgment. A well-designed agent does not blindly call tools every time. It only uses them when it is needed. Now it is the demo 4. Demo 4 is my favorite. The user asks about Coin and then asks the agent to calculate Coin's own memory requirements. The agent searches for Coin info, then computes 7 billion times 4 byte and converts to gigabytes. So first the agent thinking, it takes two tools, one is web search and then calculator, and gives a final answer. The Coin 2.57b has the 7 billion parameters from the web result, and each parameter has 4 bytes of memory. Then now it's calculate. So therefore, the total memory required, the model is approximately 26.08 GB. So this is the result. So let me show you one more thing, the full reasoning trace. This shows every single step the agent took internally. If we run it, see the output. Look at the output. Step 0 is the human input. Step 1 is the LLM deciding to call the calculator. You can see the exact expression it chose to pass. Step 2 is the tool result coming back. Step 3 is the LLM deciding to call web search, and step 4 in the result, and step 5 is the final answer. So we can see this is the step 0, which is the human input. Step 1 is the LLM decides to call the tool. Step 1 also the call the tool, but first time the tool was calculated to calculate the expression, and the second time it was the web search. The step 2, we can see that the tool result and the final result is being computed like that. The compound interest of a principal is 50,000 to an annual rate of 8% over 3 years is 62,985.6. This is the stress is incredibly useful when you are building more complex agents and need to debug why the agent made a certain decision. You can see exactly where it went wrong in production system. This is what you would log a database for monitoring. So I have built also an interactive mode. This is your homework. Try to build it yourself. When the agent can take your input from the user and it use the same tools and give the output to the user again. So this is our summary. What we have learned today. We learned a completely, from scratch we can see that we run the complete React loop, reason, act, observe, repeat, the core pattern behind every AI agent. We set up Coin 2.57b running locally via Ollama on Colab's free T4 GPU, no API key, no cost. We defined two tools using LangChain's tool decorator, a calculator and a web search. We built a LangGraph agent with a state, 2 nodes and a router that creates the loop. We ran 4 live demos and watched the agent reason and call tools, observe result and synthesize answers. And we inspected the full reasoning trace to understand the internals. That is the complete agentic system built from scratch, running locally for free. If this was useful, please leave a like, and it is genuinely help for more people to find this series. Drop your question in the comment. I read every single one. See you in episode 3. Thank you.